So chapter 4 is all about exponential and logarithmic functions. Section 4.1 starts out with composite functions, and we're going to talk more about that as they build up to us discovering and proving that exponential and logarithmic functions are inverses. So if f and g are functions, then the composite function or the composition of f and g is defined by f open dot g of x. What that means is I'm substituting in g of x in for x in f. The domain of f composed with g is the set of all numbers of x in the domain of g of x. That's also in the domain of g, so g of x is in the domain of x. Well, what the heck does that mean? They give you this lovely picture in the book. I don't 100% even comprehend. Let's go through an easy way to find the domains of function composition. This is a little bit different than I discussed it in class, so please stay tuned. Okay, first off, to find the domain of composite functions, you find the domain restrictions, i.e. what's excluded, from the domain of the inner function, i.e. what you're substituting in. If you're doing f composed with g of x, the inner function is g of x. Next, you're going to find the composition function. Then you're going to identify restrictions, i.e. what's excluded from the composite function. Then what you're going to do is you're going to find the domain that contains the restrictions from step 1 and step 3, i.e. where those two domains intersect, where they overlap. So let's work through. I have 5 examples for you. 3 of them we did in class and an extra couple bonus ones that show some special cases. That should help you with the homework and the exam. So let's take f of x equals x squared plus 1 and g of x equals negative 3x plus 2. I want to first find if there are any restrictions if I take f composed with g. Are there any restrictions on g of x? No, the domain goes from negative infinity, domain of g of x, to positive infinity. So there's no restrictions on our domain. The same holds true for f of x. Remember, f of x is a parabola. Next, we want to find our composite function. So if I take f composed with g of x, that means I'm substituting in g of x for f, in g of x in for x in f. So many alphabet letters, guys. So I have my new x is g of x. So I have negative 3x plus 2 squared plus 1. We're going to FOIL this out. Remember, we don't just distribute the negatives. Sometimes it helps to rewrite it, but it's not a necessary step. That gives me 9x squared minus 6x plus 4 plus 1. And then we combine like terms to get 9x squared minus 12x plus 5. So this is our composite function. Are there any restrictions on that domain? No, there are no excluded values, right? My range is from negative infinity to positive infinity because it's a parabola. So for our final step would be that the domain of our composite function would be where these two domains intersect. Well, that's everywhere. So the domain of our composition function is all real numbers or negative infinity to positive infinity. Now that's not always going to be the case. Let's look through another example. And in this case, I gave us our steps. So step 1, what we want to do here, I've got f of x is 1 over x, and g of x is 3x over x squared minus 1. And I want to find any restrictions on my domain of g of x. So I set x squared minus 1 equal to 0, and I'll find that's x minus 1 equals 0 and x plus 1 equals 0. So I have that my domain can't include positive 1 or negative 1. Those are my restrictions. The domain of g of x in this case would be all values of x as long as x doesn't equal 1 and x doesn't equal negative 1. Next, we find our composite function. I'm going to do that step down here. So I'm going to take 1 over, so I skipped a step. I didn't skip a step, but I didn't write it out. So if I take f composed with g of x, that is f of g of x. So I'm substituting in g of x for x and f. So I get 1 over 3x over x minus 1. That gives me 1 divided by 3x over x squared minus 1. When I divide fractions, I keep the first fraction the same. I change from division to multiplication, and I flip the second fraction. That's going to give me x squared minus 1 over 3x is my composite function. Well, what are the restrictions on this domain? Well, here I can't have 3 of x equal to 0, so the restriction on this domain is x is 0. So here I can't have the domain contain 0. Next, to find the domain of my composite function, I have to take where these two domains intersect. I gather up all their restrictions. So the domain, let me write it up here so it's real big. The domain of my composite function in this case includes the x values that were excluded from g and the x values that are excluded from our composite function, which is 0. And typically you'd want to write these in numerical order. Let's work through another example.